Hi everybody, welcome to 2.3. We're going to talk about subtraction with integers. So in the last section we added integers, and in this section we're going to subtract integers. And what you're going to learn is that there is a strong relationship between adding and subtracting integers, because subtraction is the opposite of addition. And so to subtract with integers, an interesting technique we can develop is to add the opposite. And so that's what we're going to have a look at here. So subtraction is when you find the difference between two numbers. One interesting idea is that in addition to subtraction, you can add the opposite. Instead of subtracting a number, you can add its negative. And so let's have a look here. Let's have a look at this example. They say, in fact, let's look at a simpler example. Let's look at something like this. Let's look at 5 minus 2. We all know 5 minus 2 should result in 3. Now, I chose these numbers because even though these are whole numbers, they're also integers. And so our techniques can still work. So we can say 5, instead of minus, I can say plus, instead of 2, negative 2. So you can still see that I'm doing the minus 2. It's just that I'm adding a negative instead of taking it away. And this is sort of like, instead of spending money, maybe adding debt. So it's still the overall same net worth for a person, right? Whether they spend money they have, cash they have, or they borrow money against cash reserves they have, it's still the same effective net worth. So 5 minus 2 is 3. 5 plus negative 2, if I'm thinking about the number line, if I start at 5, I start here at 5, and then I go to the left 2, that's like taking away. So 5, and then go to the left 2, I'm left with 3. Now, the reason that adding the opposite is a useful technique is because it can help us with negative numbers. Especially when we're not sure exactly what the sign is supposed to be, right? So let's have a look at this example here. So here's the example. It's negative 7 minus 2. So I start at negative 7 and then I take away 2 more. I can think about this on the number line. I start at negative 7 and then I go to the left 2. So I'm actually going more negative, right? This is like, I already owe $7 and then I'm going to borrow $2 more. So I'm actually going to end up owing even more money. And so one way we can think about this is negative 7 plus negative 2. So instead of subtracting 2, I can add a negative 2. So it's the same thing. I can add the opposite. So negative 7 plus negative 2. So I'm taking a negative and then I'm adding more negative. So I'm going further and further into debt. All right, let's have a look at a situation where I'm actually subtracting a negative. So I can see here, I'm supposed to take 12 and then take away negative 6. Now here's an interesting situation. Taking away a negative. So when I take away a negative, that's like taking away debt. Well, what is debt relief? That's free money, right? So debt relief is free money. So in this case, if I take away $6 in debt, taking away $6 of your debt, that's like giving you money, right? That's the same as giving you money. I've just given you a free $6 by relieving $6 of your debt. And so instead of 12 minus negative 6, a really useful way to think about this is adding. So instead of subtracting, I'm going to add the opposite. What's the opposite of negative 6? Positive 6. So instead of taking away a negative, you can think of that as adding a positive. And then that's much easier to do. So 12 plus 6 is 18, and that's much easier for me to get my head around conceptually than taking away a negative or taking away debt, even though we know it should get to the same result. And so this is why sometimes we say a negative next to a negative makes a positive. Because what we really mean is if you're taking away debt, that's like getting something for free added to you. So hopefully that kind of makes sense, and with some practice you'll get it and ask any questions you have. So have a look at this table here. We'll just look at a couple of these together. So you can see a situation where when it's subtraction, right, regular subtraction, you may be able to do it on your own. You may be able to say, oh, well, 7 minus 9. If I have 7 and I try to take away 9, I don't have enough to give, so there's 2 that I would owe if I tried to spend 9. If I already owe 7 and then I take away another 9, I'm trying to spend money I don't have, so I'm going further and further into debt, so the signs are going in the same direction. If I start at negative 7 and I go 9 more to the left, it turns out that's deeper into the negative territory in negative 16. So when I'm subtracting, sometimes it just makes more sense to think about the number line. Think about a real world example where I might start with the number on the left and then move some number of places based on the number on the right, either positive or negative, depending on whether I'm adding or subtracting. But you could see a situation like the next example, 7 minus negative 9. This is a situation where it would be very helpful, instead of trying to think about, okay, well, what happens if you take away debt? That's like adding. Instead of that, maybe it's better to think about, instead of taking away, adding the opposite. So I turn my first minus into a plus, and then as long as I add the opposite of whatever I was adding or subtracting before, then I'll get the same result. Since it was taking away a negative, that's the same as adding a positive. And so you can see a situation like that. It might be more useful to add the opposite. What about this situation? Negative 7 minus negative 9. Okay, so I owe $7, and then I take away $9 in debt. It's a little confusing. Maybe you're not sure exactly where we're going to end up. So what I'll do is I'll rewrite the first number, and then instead of subtracting a negative, I will add the opposite. Oh, okay. So if I have negative 7, if I start at negative 7, and then I go to the right 9, or if I owe $7, and then I make a $9 deposit, it covers the $7 I owe, and I have 2 remaining, 2 left over in the positive. So hopefully this technique helps you. I'll let you do these last 4 here on your own as examples, since you have the answers and you can check your work. And if you're confused, please let me know, and let's go over it together. Okay, so now that we can add and subtract integers, we can follow the order of operations, adding and subtracting integers. So they want us to simplify this expression, negative 3 plus 6 minus 2. So they want us to combine like terms, right? They want us to simplify as much as possible. So since it's all addition and subtraction, I have no parentheses, exponents, multiplication, or division. I'm going to do addition and subtraction from left to right. And so then the first addition or subtraction problem I encounter is this negative 3 plus 6. And so negative 3 plus 6, if I start at negative 3 and then I add 6, right? If I have $3 in debt and I make a $6 deposit, I'll be $3 in the black again. And that's good. Now I'll bring down everything else that I didn't incorporate into this answer. So negative 3 plus 6 simplified into just 3. The minus 2 is still hanging on until I'm ready. So I can think of this as 3 minus 2. And in fact, instead of thinking of it as adding the opposite like they do here, right, 3 plus negative 2, I think 3 minus 2 is probably easier. So I think you should pick and choose when to rewrite things so that they look clearer to you, and when to work with what you have, because it is actually as clear as it could be. So 3 minus 2 is one of our key subtraction facts that we know. So 3 minus 2 is 1. So then that is the simplified version of that expression. All right, we'll do another one. This time it's in words. It says subtract. So we know it's a subtraction problem. Plus it's 2.3, which is all about subtraction. So we knew it was probably going to be related to subtraction. Subtract 3 from minus 5. Now, if I go from my house to work, then I start at my house. I start with the from, and then I do the movement, right? Whether it's driving away or subtracting 3, the from indicates where we start. So subtract 3 from 5, it's not 3 minus 5, it's actually taking away 3 from an initial place of negative 5. So that's what subtract 3 from negative 5, looks like. Now in this case, I could think of negative 5 minus 3. Maybe it's not super clear exactly what I mean. So let me rewrite this as an equivalent expression. Negative 3, instead of subtracting 3, negative 5 minus 3, I'm going to add the opposite. So instead of subtraction, I'm going to add. Instead of 3, it's negative 3. Now it's a little bit clearer that negative 5 is my starting point, and then I'm going to go 3 units to the left. I'm actually adding debt together. So I borrowed $5 one day, and then I borrowed $3 the next day. So now I've borrowed a total of $8. All right, we're going to have a look at some data and see how negative and positive numbers, integers in general, kind of interact with each other in real life situations. So you could think of a situation here. These are temperatures. These are record low temperatures in Denver. And what we can do is we can see, in the winter, they are negative lows. And then in the summer, they are positive lows. And so if you wanted to know the difference between one temperature and another, you could subtract and find that difference. And so that's one thing that we'll have a look at here. So the data has been made into a scatter plot. So each one of these points, so for the month of January, they came over to January, and they plotted on this axis here, they plotted the temperature. Now, because the temperature goes below 0, 0 is not going to be here at the bottom. It's going to kind of be here in the middle, right? That's where the 0 is, 0 degrees Fahrenheit. And so anything below that we know is negative, and anything above that is positive. And it makes sense that in the winter you would be low, and then you would move up in the summer. And you would have kind of a nice curve going from warm to cool and back down. So they want us to kind of understand how maybe, what is the difference between the low temperature in February and the low temperature in May? What is the difference between the low in February and the low in May? And so in February, the low was negative 23. And in May, it was 21 degrees. So what's the difference there? How can we figure this out? Should I say, that's 23 minus 21? No, I shouldn't, because that doesn't preserve the positive and negative relationship. And so it's crucial that I preserve that. Now, interestingly, it actually doesn't matter whether I start with May and subtract February or start with February and subtract May. In one case, I'll get a positive answer. In the other case, I'll get a negative answer. But the absolute value of the number will still be how many degrees they are apart. And whether it's positive or negative will be all about perspective. You'll see what I mean here. So let's have a look. So what's the difference between February and May. What's the difference in temperature? So I can see over here in February it's less than 20 degrees below zero, and in May it's closer to, let's see here, it's closer to 20 degrees above zero. So what's the difference between 20 degrees above zero and 20 degrees below zero? That's a 40-point swing. That's a 40-degree difference from one temperature to the next. So whatever subtraction process we use has to preserve that relationship. It has to show that the negative and the positive are moving in different directions from zero, and so actually it's a larger gap than it might appear. And so let's have a look. So February, we're starting off at minus 23 degrees. And then in May, I'm getting up to 21 degrees. And I want to find the difference between these two numbers, so I will subtract the difference between these temperatures. Now I have a couple of choices. I can try to think about subtraction like this. I have to know that if I start at negative 23 and then I go to the left 21, I'm going more negative. Or I can think of this as starting off here and then adding the opposite. Oh, but I didn't add the opposite, did I? Because instead of subtracting positive 21, I'll add negative 21. And so writing it like this can be sometimes clearer. I start at negative 23, and then I go to the left 21 more. So I'm actually making a bigger negative number. I'm adding two negatives, so I'm going to stay negative because I'm combining the two numbers. So 23 and 21 makes 44. So it was actually 44 degrees Fahrenheit difference between February and May. Now the question is, why the minus? Well, if you're looking at May, if you're starting from May and thinking, well, how much cooler is February? Then February is 44 degrees cooler than. But if you were to start in February, you'd be thinking, actually May is 44 degrees warmer than February. So it kind of all depends about which month you're using as your reference month. And then remember, the absolute value of this number in many ways is the number that we care about in normal language. I would say, oh, well, what's the difference in temperatures? Oh, it's a 44-degree difference in temperatures. That's what I would say. I wouldn't say, well, May is 44 degrees warmer than February, or February is 44 degrees cooler than May. I would probably just say it's a temperature swing of 44 degrees, which is pretty dramatic. All right, let's review the concepts here. So we will kind of review some of these problems and make sure that we are ready to move on to the homework sets. So 5 minus 3. We can do 5 minus 3. We know that the answer is 2, but they want us to write an equivalent addition problem. So what I can do is I can say, oh, well, instead of subtracting, I can add the opposite. And the opposite of 3, of course, is negative 3. So I've written a subtraction problem as an equivalent addition problem. I can always add the opposite if it's easier than subtracting. And that's all I have to do. I just had to write it like that. B, explain the process you would use to subtract 2 from negative 7. So if I'm going to take 2 away from negative 7, then that actually means that negative 7 is my starting point. And I'm going to take 2 away from negative 7. Now in this case, I do think it actually makes a lot of sense to, instead of subtracting 2, to add the opposite, which is adding negative 2, because then I can clearly see negative 7 and another negative 2, so I'm going deeper and deeper into debt. All right, C, write an addition problem that is equivalent to the subtraction problem negative 20 minus negative 30. Negative 20 minus negative 30. Okay, I'm not sure about that. But we don't actually have to find the answer. We just have to write an equivalent addition problem to the subtraction problem. So instead of subtracting a negative, I'm going to add the opposite. So I'll still start with negative 20. That doesn't change. But then instead of subtraction here, I'll add the opposite of negative 30 is positive 30. So negative 20 plus 30 is equivalent to negative 20 minus negative 30. And hopefully you can see why we might want to do that, because sometimes it's going to be much easier for us to work with an expression like this. It just depends on the context. D, why is it important to think of subtraction as addition of the opposite? Well, I would say it's for a couple of reasons. One is it can make problems much easier to actually work on. And the other reason is because addition and subtraction are opposite operations of each other. They're inverse operations of each other that undo each other, right? If you add 5 and then take away 5, you're right back wherever you started. And so it's really important to understand that they are related operations that happen at the same time from left to right. And that's why it's so important that we be able to rewrite subtraction as addition, if it ever helps us to simplify an expression more quickly. So I would say there's kind of two things. One is can make problems easier to work on. So it can make problems easier to work on. That's one reason. And the other reason is because addition and subtraction, they're really two sides of the same coin. So they're related. They're twins in many ways. They're twins of each other. They're just each other's opposites. So they're related. All right, so those are the ways that I might write it. I'd like you to write it in your own words. And as always, please be in touch if you have any questions.